Python web conference. Welcome back. I am super honored and happy to be joined with Andrew Godwin to give our keynote for this afternoon. I hope you all will enjoy this as much as I'm getting ready to enjoy this. So without further ado, I'll let Andrew take it away. We will join in the face-to-face afterward, and I'll do some closing remarks after that. So that's all that needs to be said at this point. I'll let Andrew take it away.
All right, thank you so much. Hello, everyone, and it's a pleasure to be here. Even if it's only virtual, I am glad you are all around, and it is my honor to be invited to give a keynote at Python WebConf. So just to give myself a little bit of an introduction, if you're not familiar with me, I'm Andrew Godwin. I've been around the Django community for, I'd say a little bit of time now, about 2008, 2007. I've done a lot of things in Django, like migrations and channels and some of the async work. And of particular note in this presentation, I'll talk more about it later, I have been dabbling with Python async on and off since about 2009. So it is one of the things like it's always been on my radar. And then the last few years, it's kind of sprung up. And I discussed some of that in context as we go through here. I'm speaking to you from the lovely city of Denver, Colorado. It is beautiful here, if not a bit snowy. And while I do miss seeing everyone in person at conferences, online events like this are fantastic. So it is lovely to see you all, and I hope you are all doing well. You're all staying safe, and hopefully I'll see some of you in the fine state of Colorado at some point in the future. But let's talk about the talk. And like any good story, there are three acts: the past, the present, and the future. In particular, like what I'm trying to go with this talk is like giving you an idea of like, what is the Python async world like, and how does it particularly apply to the world of web? Like Python has many different footprints in many different areas, right? Data science and processing and other things. But web has always been a big part of Python's history. It's what got me into Python in the first place from PHP. And so I first want to talk about the past and like what set the stage for where we are now. Then I want to talk about the present and like where Async.io is, how you can do things right now, and how things like Django and Flask are dealing with it. And then if you've ever seen one of my talks, I love opining about the future. So we'll talk about the future of async, what it can mean, and what it means for you in particular as a web developer. But of course, let's start with the past. And I would be, terrible person if I didn't first of all mention that like Python is not alone in this. We are a community of languages that all work together as programming languages. Python has stolen ideas from other places. Other languages steal ideas from us. That's just a part of the way it works. Many of the ideas that Python async builds on have been lifted from previous academic work of previous languages. And in fact, some of the ideas have gone on to be in other languages themselves. And if there's one thing that's true about all async stuff in pretty much every language I've seen, it's really tough. Just one look at like, for example, Rust's adventure with trying to add async into their code base. Like Rust is a really great language written really well. Even then, like as we'll talk about during this talk, there are some really interesting problems with how to do that properly and safely that in particular they have to address because, it's a very safe language. But overall, that's kind of the way it works. But let's talk about Python's history specifically. This is kind of a brief history in terms of more how big it is on the screen than length of time of Python's async history. It starts off back in 1998 with the introduction of both the threading module, which is your very basic, nice, high-level wrapper around OS threads, with a few trade-offs we'll talk about in a second, as well as stackless Python. If you've not heard of stackless, it was most famous back in the day for being the basis of the EVE Online servers. It's a really interesting variant of Python. I'm not going to talk too much more about it here, but if you are curious about what you can really do with having loads of parallel threads in a very slightly different version of Python, it's fascinating to go look at. As we go through history, you can see things like twisted, coroutine generators, greenlets. We'll talk all about these in particular. And then at the very end of this timeline, we have 2014, which is actually the first time that Async.io was introduced. Now, you may be thinking, that's weird. That's a lot earlier than I heard about it. And that's true of a lot of those things. If you think about that time period, and if you're not familiar with it, that's when Python 3 was being sort of born from almost nothing. And we were running separate parallel versions of Python 2 and 3 in most places. So Async.io was initially created back then, but it's gone through a lot of growth and refinement in that process. And so some of the things I talk about here have been on development for 6 or 7 years. And like, just bear that in mind when you think about these things. And people often don't realize, for example, that Python is actually an older language than Java. It's like this weird, like rooted in history thing where to some people, like, oh yeah, Python, it's this new upstart language. It's 30 years old. At this point, it's been around for a very significant portion of computer engineering's history. So let's start talking about threading and multiprocessing. And I grouped these together because they have very similar APIs, which honestly is kind of an amazing feat on the part of multiprocessing. You make a thread, you give it some code to run, and then the Python interpreter just takes that code and it literally time slices that code in the threading module with other threads. The more threads you add, the more time slicing it does. And crucially, Python will always try and hop through each thread and give it equal time. Unfortunately, the cost of that context switch is very high. So this is one of the reasons that threading was never enough for us, even for doing asynchronous or background work. As you add more threads, the Python language interpreter spends more and more and more time just in context switches rather than running Python code. At some point, I think it's about 100 threads. On some processes, you start to cross a boundary of it spending more time on context switching than you're spending on actual running of code. So it's useful for parallelizing 2 or 3 things. It's not useful at large scale. Multiprocessing, again, is like a better version of this. Threading is just one CPU. Multiprocessing takes this idea of threading. We have like a class with a thing that it runs, and instead it uses clever system forking to run that code on separate system processes. Now, this works really well if you want to use multiple CPUs and really jam on things. But that same problem you have with threading, of not being able to run too many things at once, kind of is increased with multiprocessing. Not only do you have like an OS level limit on just how many things you can run at once sensibly, that's pretty high in most modern OSs. You also have the fact that it's having to do a memory copy for each of those different processes. They are, in most systems, copied on write. So like when you initially fork off, there's no extra usage, but it really builds up over time. And as we'll discuss later on in the presentation, memory pressure is probably the main thing that informs architectures on the web these days. And so generally, that's not an amazing system to serve stuff. That said, you generally see both of these paradigms used in modern web servers on Python, because if you do like 8 or 16 worker processes, it works really well. And that's kind of where the trade-off lies. And we'll talk a lot about trade-offs, trust me. So next, let's talk about Twisted. In my opinion, Twisted is Python's very first proper asynchronous framework. Now, you may not have used Twisted, which is a shame. It's a really fascinating language. And it essentially like has the idea of deferreds, which these days are called promises, for example, in JavaScript, that kind of idea of it, or a future in Python. And it built this whole system of asynchronous deferreds and callbacks and errorbacks and all these handoffs that in some ways, I think, were repopularized by JavaScript about sort of 4 or 5 years ago when they had the big callback stacks. That was all there back in Twisted's day in the early 2000s. It was, of course, grappling to do it in a language that didn't quite have the keywords it wanted. And so a lot of it's kind of more verbose than it should be. But it was a true asynchronous system, as we'll see when we discuss how they work. It has a core reactor that sort of everything feeds into, and it waits for an event to happen. And then based on what the event happens, it fires the right thing off. And Twisted is still around, to their credit as well, especially. Twisted has adapted to use modern Python language keywords. So if you last saw it back in the days of adding callbacks and deferreds, you can now just use things like yield and await. And some of those things are built into Twisted now. It just uses those parts of the language. One fun piece of history, Twisted is the very first thing I wrote asynchronous Python in. Back in, I believe it was 2007, based on looking through my archives, preparing for this talk. I wrote a Minecraft server in Twisted called mine, very inventive, I know. And that was my very first thing. Like, that's a difficult problem. Minecraft servers, if you're not familiar, lots and lots of storage space, big 3D space, very difficult, but like it performed admirably in that process. The main problem was my water physics were far, far worse than any networking code there. So I have a lot of respect for Twisted. It's an amazing thing. And one of the foundational building blocks of, I think, Python's modern async stuff. Then we get to, I think, maybe more familiar to many web developers, which is Greenlets and especially GEvent. Now, what this is a much lighter weight version of threads, a little bit like stackless Python, but a bit of different flavor in there as well. And essentially what this does is it lets you run lots more threads in parallel, and again, trigger them slightly more intelligently than just doing basic time slicing. Now, there is a really big bonus to GEvent specifically, which is like, if you just import GEvent and let it monkey patch everything, it's kind of a drop-in solution. You can just take GEvent and go, oh yes, just install it and then monkey patch all the socket libraries and request library and everything. And it generally kind of works. The main problem with that is that it mostly works. And then the 5% of things that don't work are some really, really interesting areas that I have had the pleasure of spending hours debugging. So it's an amazing tool if you use it correctly. I don't think it's quite comparable to sort of the async stuff I talk about here with Async.io, but it is useful if you apply it the right way. I will say I prefer if people apply GEvent specifically to certain modules rather than just monkey patching everything, but that is of course a personal choice based on how you develop. And then I think most crucially, the kind of inflection point was two different pieces kind of spread far apart in Python's history. First of all, you had generators that could yield things. So initially generators were just a thing where like, oh, you can make a lazy list where you yield things back from the inner function to the outside. And then the ability to yield things back from the outside into the function happened. If you think about it, this is when you want to get a result from an asynchronous call, you are doing essentially a yield that you want a result back from. This yield from ability is kind of the foundation of what we consider modern Async.io in Python. And indeed, it's what Guido van Rossum built Tulip on top of. If you're not familiar, Tulip is kind of an initial proof of concept of exactly how you might do generator-based async in Python. It was not the first, it was not the only one. There are many different implementations of this. I think I even wrote a toy one back in the day. Everyone saw the potential for what could happen there. And I think it was all these facets bringing it together into one that made the cohesive whole, like, oh no, we can actually build an entire asynchronous system around this concept. So that's the kind of overall timeline. As you can see, it kind of takes about 2 decades-ish for us to go from the initial idea of threading. And honestly, back in the late 90s, asynchronous processing wasn't really as hot as it is now, just because there are very different considerations about what it meant to get top performance out of a computer, and also the kind of processing loads that we were all working on. It was very different back then. As I'm sure those of you who are around and coding at that point, rather than in school like I was, can talk to. But crucially, what did we learn from that process? What did we learn from almost 2 decades of going through different asynchronous stuff? Well, we learned a lot. Different paradigms were experimented with, different ways of doing async were done. But I will say we didn't learn everything. As I'm sure you can all appreciate, there is always a portion of a project that just never fully materializes until you actually go for it, until the rubber hits the road, as they say. And that's kind of true of Async.io. It did come out in some ways pretty close to the original vision, but it turned out there are a lot more things to do in there. I think there still are some things to do as well. And that's what we'll talk about here. Let's talk about the present. And of course, when I say present, Python still has several different async frameworks. But of course, the dominant one here is Async.io, the one built into Python core. Now, some of the other ones, like Twist is still around. Trio is a really interesting other one. This is await syntax. I love both those projects as well. I think they have some really interesting trade-offs with Async.io. But in the end, in some ways, the thing that matters is where is everybody's support gathered around? The strength of open source software is often not in just how perfect the software is, but in the community and the support around it. One of the things that drew me to Django, like Django is not a perfect framework. It never has been, probably never will be. All of us will admit that. But it has an amazing community around it, and that's what makes it tick. In some ways, that's one of the reasons Async.io is the place to look, because having that support, having those libraries is really important. And it is gaining traction. It's really taking off. In the last, 3 or 4 years, I've kind of switched to doing some async talks, some migration talks, some other stuff. But like as I've gone through making these talks and doing them, I've really seen that take off. It has been phenomenal to watch things like database drivers add support for it, to see like good replacements for like doing requests to HTTP and stuff like that. Like these days, like as I stand here talking to you right now, honestly, I would say that you're in a place where you can probably just write a pure asynchronous app and it'll be pretty good. That's not a thing I could have said even 2 years ago. If you're not familiar with how Async.io looks, this is the kind of basic way the code happens. The key thing is, rather than doing a normal function call, you do a thing called an await. And what the await does, it signifies to Python, hey, I want you to pause this coroutine, this execution context, and go away and come back when the thing I awaited on is ready. And again, this is different to the way threading works, right? Threading just always checks in every thread and goes, are you awake yet? No. Are you awake yet? No, and comes back. Whereas this kind of evented model, literally the core reactor or the event loop sits there and goes, okay, I know that after, for example, in the case of the top one here, 1 second has passed, then I should go back and wake it up. Or I know once this socket I've got open has data on it, I should wake them up. That's the kind of difference it has. And if you think about how that kind of event loop system works, it looks kind of like this. You know, the loop part of event loop is very descriptive in that, like, all it is a core piece of Python code. It has a load of coroutines and a big data structure. It goes, okay, let's check our sockets and timers and make sure they're all ready and like draw down the bytes. And then let's go through our set of coroutines and find any one of them which is ready, be that the timer is expired, be that there's data on its socket, be that something else, right? When it finds that, it runs the task, and it runs the task until that task awaits again or returns. And once it's done, it comes back, puts that task back in its queue, along with any new tasks that were spawned, and then just keeps going around. Now, one thing to understand is it's still fundamentally using a single CPU. It's just a different kind of time slicing. Rather than being equal, it time slices in what's called a cooperative way, where you as a process or as a coroutine have to correctly yield when you're doing something. In the good case, like you see on the slides here, that's fine because all the different coroutines get exactly the amount of time they need, and there's some idle time when no coroutine wants to run. That's perfectly fine. But of course, it is cooperative. And that means that if you don't yield, if you don't await when you're supposed to, and instead, let's say, you know, you have written some code where you go off and do stuff, well, bad things happen, as we'll see. This is one of the parts of what makes async very difficult. One of the refrains you may have seen in some of my other talks is that async is a hard problem to solve. And this is true of any kind of, you know, parallel processing in general, be it async, be it threading, be it running it on multiple computers in a big cluster. They all have synchronization problems and problems about how to run things in parallel. And one of the key ones in async is that cooperative problem. Because everything must cooperate, you have to make sure you have no synchronous code. If I have a wonderful, let's say, you know, fully asynchronous web app, which serves all like, you know, 1,000 requests in parallel super easily because everything's done async properly. And then somewhere I accidentally put in a synchronous call to, let's say, an external web service. It takes, you know, like 500 milliseconds, which is an age in computer time. But as far as Python is concerned, that coroutine hasn't yielded. It hasn't run an await clause. And so the entire Python interpreter will lock up, waiting for that one synchronous socket to return and not run any other coroutines. This is maybe the biggest problem with cooperative multitasking. It's a big trade-off, of course, and there's a reason it's good as well. But it's one thing to be really careful about in your Python code. Python does have built-in things to detect this, where like if you spend too long on one coroutine, you can turn on a flag where the interpreter will go, huh, you spent more than 100 milliseconds coroutine, what are you doing? And it will warn you about this stuff. But it is kind of one of those silent failures where like everything could work really well locally in development when everything's like local and talking to each other and network responses are really quick. And then once you go to like the real world, run on servers and you have like 1 second responses, that's when things really drag. So it's not an amazing class of error to deal with in that sense. The other problem, and this is kind of in some ways the way coroutines and async were added onto Python, you can't actually tell if a function returns a coroutine before you run it. It's kind of a weird sort of like you can't tell what's inside the box until you open the deal. The reason for this is this. So Python has two ways of doing coroutine-based functions. The top one here is the standard one you'll probably see in most places. It's an async def that tells the Python interpreter directly that, hey, this is an asynchronous function. When someone calls the function, return a coroutine. Because crucially, when you call that function, it returns a coroutine, and then the await keyword takes that coroutine and runs it. However, you can also do the bottom style, where you have a normal function, but still returns a coroutine that you have to await the result of. And Python can tell you from like the inspect module, the top one, you'd be like, or even the async module, that, hey, is this a coroutine function? It'll go, yes, this is a coroutine function. It's got async def on it. It can't tell you the bottom one. And so what that means is it's always kind of a game where, like, for example, in Django, we let you write both synchronous views and asynchronous views. And if you write an asynchronous view as async def, great, we can detect that and just do it automatically and make it work. If you write an asynchronous view for some reason as a normal def without the async keyword, we can't actually tell what it is. And Django will catch the coroutine falling out and go, you gave us a synchronous function that returned a coroutine. You need to decorate it or make it not return a coroutine. So these are kind of errors you have with like trying to make a system that works in both worlds. And working in both worlds is kind of one of the biggest problems with modern Python async, because of the fact that you can't tell what a function is until you call it. That also means you can't have one function be both an asynchronous function and a synchronous function, because even in asynchronous mode, Python will call your function and expect you to return a coroutine. In synchronous mode, it will call your function and expect you to return a result. And it gives you no indication when it calls your function what mode you're in, because of the way it's written. Again, remember, this is all kind of like built on that generator system and like added on over years and years and years. It's built on the original idea of functions. There never was a distinction back in the old days, so there isn't one now. There's one thing you can do, which you can try and look for a current event loop in the current thread, but it's very hacky and doesn't work all the time, especially in tests. And so what this generally means is you end up having to literally take all your async functions and namespace them. You need to have a separate set of synchronous functions and of asynchronous functions. This, as someone who is very passionate about good API design and good framework design, is maybe the thing that makes me saddest. It is a very obvious outcome, and in some ways it's very good. Like, explicit is better than implicit, as we always say, but it does mean you end up with things like this. So Django is, as we'll talk about in a bit, halfway through the asynchronous, like adding on stuff stage. And one of the things we have to still do in the future is make the ORM do both synchronous and asynchronous modes. Now, again, it has to do both. We're not going to replace sync with async, as I'll talk about later. That's not sensible in my opinion. But what this means is we have to do things like you see on the slide here. We have to do stuff where, like, oh, well, there's a synchronous get and there's an asynchronous get that's in a different place. Now, we're still not quite sure. It's going to be like you see here with a .a, and then the normal set of functions. It could be like .async get, but something has to be fundamentally different in the name of those things so we can tell from the Django side, oh, you called the asynchronous version, you were expecting that. And it's interesting because some things like filter, it doesn't matter. If you're not familiar in Django, when you do filter on query sets, it's lazy. It doesn't actually run any database code. It just sits there building up an internal query. So we can support filter just fine, but like .get and .values are the ones that actually do queries, and those actually need to have an asynchronous version. And so again, you're like, well, do we mirror all the ones that don't need an async version into the async namespace so you can just put .a everywhere? These are the kind of questions that kind of two worlds thing introduces. And in terms of things that Django has done already, the two worlds thing extends to the request flows. This is an example of what is in Django right now. Django, as of Django 3.1, the last release, fully supports both synchronous and asynchronous servers and views in any combination of the two. And the only way we can achieve that is by literally writing a fully parallel request flow, as you see here, where there's a different specification even. There's WSGI and ASGI. There's a different application handler. There's a different request class. There's a different like dispatcher. The URL system is one thing we can redo, but middleware is also adapted as well. And under the hood, Django does all this for you. It tries to adapt the middleware across to live in the other world. But in general, it's a really tricky problem. Like, fortunately, Django's architected in such a way by those before me that pulling this off wasn't too difficult. It was, a few weeks or a few months of testing, but generally there was pretty good separation of like the logic from the input-output code in those handler classes. And one of the reasons for this is that Django predates WSGI. And so Django's always had the separation of, well, we might be called directly, we might have CGI, we might have WSGI, we don't know. It's like that piece of code archaeology, even though Django's only had WSGI for a long time, we kept that separation in there. I could use it again for ASGI back when I added that in last year. So like that kind of timeline was really interesting of like, in some ways, the past always reflects the future. But of course, as I said, in many ways, the future is already here. You can just write fully asynchronous Python now, and it does work pretty well. Databases are adding support. It's not all the way there yet. And of course, like intermediary things like SQL Alchemy or Django's ORM haven't added them, and in some cases won't add them. It's just a lot of work to do. But it's a thing you can do in theory. And Django even gives you some helpers to, like, if you want to run some ORM stuff, we have a way of wrapping it sensibly at least, so you can try and do it in a way that doesn't lock up the whole server. And so let's talk about, like, given where we are now, where we stand, what does the future hold, right? Like, we're kind of on the precipice of asynchronous being a thing that is just readily and freely available in Python, a thing you can use whenever you want to. And I think then the question becomes, when do you want to use it and why do you want to use it? And that's, I think, really important, especially, you know, some people work on big batch data processing systems. Those don't have quite the same need for real-time response, right? Like, it's like, well, we want to be efficient. We want to use the hardware in the best way possible so it runs in, let's say, 4 hours rather than 12. But it doesn't matter that getting a response back in, say, 100 milliseconds. In the web world, we kind of live in a real-time world, for better or for worse, in some way or another. We have to get the responses back to our customers, like 500 milliseconds, 1,000 milliseconds at the outset if you're doing a good application, right? And that difficulty, I think, directly ties to async. And as we'll talk about in a bit too, the changing face of the web over the last 5 years and the next 10, I think also changes what we do as Python web developers and also what the sort of ecosystem in general demands of us. So, I mean, the obvious thing in the future, and this has always been the refrain from everyone, is that we need more library support. Like, we need support from all the major databases. We need support from all the major networking protocols, all the things that do input output, basically. You don't need things like, for example, like, I don't think NumPy would ever get there because it doesn't make any sense in that context. You could run it in a separate process if you wanted it. It's very heavy. But all the things that talk to other stuff, that probably has to have even better library support for things. As an example, like things like gRPC for talking between services have to have it as well as databases. Basically, anything that exits from just your program and goes somewhere else probably needs async support if you're going to put it into a full async application. But I think when people go on that refrain, it kind of hides the real problem. I am a big, big safety nut. And when I say that not only in terms of, personal safety, working in workshop stuff, whatever, but also in terms of code safety. One of the reasons I was drawn to Django initially, and the reason I still work on it, is that it's very safe by default. We don't give you many or any easy ways to kind of take Django out of the box and shoot yourself in the foot. Like things like the debug page really warns you and stuff like that. It usually works, it's got a bit better. And in my opinion, a good framework or a good system is one you can build code on where if you just do the naive thing, either you get safe code or the system explicitly fails and explodes. In my opinion, the very, very worst thing is what I call silent failure. Now, you've all seen this. It's when you have a kind of failure that never makes itself known in development or in low traffic modes. There's many, many classic examples of this. Race conditions, deadlocks, all the standard multiprocessing stuff is in there, for example. There's many other ones too. Silent failures are my particular bugbear. For example, if you use Django and you are in an async view and you try and call the ORM, there are two ways we could have handled that. The first way is we could have gone, well, you can technically run synchronous code in an asynchronous function, like it will block the whole function, but it's not our place to worry about it, and just let you run it and block everything. Or you can do what we did, which is if we detect you're in an asynchronous view, the ORM explodes on you and says, don't do this, call it in a synchronous thread, and here's how, and here's the docs. That to me is the good kind of failure. It's very explicit in your face failure. And there's a whole new class of things with asynchronous code we have to make safe and protect. And in many ways, it's one of those things where synchronous code is much easier to write. Our brains think in that kind of linear train of thought, at least for most of us, where we go like, okay, I want to do A, then B, and then C. And they can't really comprehend how if we give a system A and B and C, they may execute in any order, in any interspersion with any gaps between them. Like in some ways, the whole genre of modern processors is a giant lie around their asynchronous execution calls. They pretend to do things in order, right? They actually go off and do branch prediction. And so it's all of these kind of things that in some way we have to really sit down and try and make sure that like we can give all of us as developers these tools and we can use them safely. And I'm not talking here about a junior versus senior divide. Like I have seen many senior developers, myself included, make the most stupid mistakes. We all do it. It's just a case of when and if you own up to your failure, right? And so to me, this is the really important thing to think about. And on top of that, all of this is added onto the current workload. It's not like Django is just done and idle apart from this, right? It's not like I can just sit at a day job and go like, well, we're not got any work on right now, so I can just sit here and convert the entire company to run on async. That's not how it works. It's always a trade-off. It's always a priority situation. And so how do you sit there and like, if you are not doing a new project, even then doing a new project, you have this particular situation, how do you go, okay, I'm going to trade off doing feature X to instead do async over here? And of course, it's not just a feature comparison. One point I always make to people on the product side especially is that fast response times are a feature, and they're one of the main features of a good website, but it's still an argument you have to have. And in many ways, the way I settle down is that the most important thing you can do is horizontal scalability. If you're standing there with a young website or a young service being like, well, it runs on one box right now, we can make it run async and get a bit more out of that box, or we can make it run on 10 boxes or 100 boxes or 1,000 boxes and just have that slider, you absolutely should do the second thing. There's no question about it. Async will always get you a bit better performance, but you are going to hit a wall if you can't scale horizontally. And I think that is the number one thing you should always be concerned of with your architecture. But that has started to change. Remember I said the web is changing around us? Well, it is. Like, 10 years ago, single page applications and rich JavaScript wasn't nearly as much of a thing as it is now, right? Like we had a couple of them. They were like one-off expensive constructions. But now the world of how you make applications has changed. And I would argue for the better. In many ways, the web has become a new OS. Accessibility is so important though. It's one thing we've got to work on, but it's here and we have to deal with it. And one of the things applications love and users expect from those kind of applications is much more real-time interaction. And there are generally two efficient ways of doing this: long polling, which is where you hold a connection until an event happens, or WebSockets, or sockets in general. Both of those do not fit well into the standard Python web model of we have one thread or one process per request. Because guess what? If I have one process per request and I have 100 users with 2 tabs open each, you've just eaten up 200 threads and they're all doing nothing. You're going to look at your box and be like, that's weird. The memory is completely full, but the CPU is at 0. Remember I said like memory scarcity is the number one thing we build to? Absolutely true here. So instead, like we need to think about both how things are now, like, a lot of APIs, a lot of calling things, GraphQL is coming in as well as REST, stuff like that. But also the future of like, well, as applications become more dynamic, they need things more real time. You can hack it in with short polling. It does work for a while. I kind of class short polling, which is like polling every second. Is it there? Is it there? Is it there? I kind of class that as like almost a silent failure, because that number of requests adds up so quickly and you'll quickly find yourself drowned in short polls, and just like the overhead of serving them all will just kill you. So in that way, when I look at the web and how it's going to go, I don't see it here going like, oh, everything should be async, right? There's clearly a portion of the web that doesn't have to be async. If you've got a simple API where like I call the API, it does some complex business logic in the CPU and then returns me an answer, that does not need to be async. I have no gain from it. It'll just make your life harder. It will introduce more bugs. However, if you've got a big microservice-based system that talks to each other and has parallel queries, you would absolutely get a massive performance benefit from having async code in there. And so in that sense, I always think you should have both. You can see that design philosophy as we build out Django, where like Django is adding async onto the side as a co-existing environment rather than just replacing everything. Like people were so scared of it, like, Andrew, you're going to remove all the synchronous stuff? Like, no, of course not. Like I write synchronous code most of the time. I only bring in async code when I think it makes sense. And that's the key thing. Some things do not need asynchronous code. It is sometimes even a little slower, and that's fine. It's kind of the law of premature optimization. You never want to prematurely optimize, and that's true of both running things in async versus sync. Unless you absolutely know the shape of the thing you're writing would benefit really, really strongly from asynchronous code. Let's say, I'm building a WebSocket endpoint. Obviously, you should start in asynchronous mode. No questions about it. If you're just building like a pretty complex API that maybe could be called in parallel, you want to start off synchronous, build it out, get your test suite in place, make sure it all looks good, make sure everyone's happy, profile it, and then come back and add async to the pieces that are slow. That's the way you want to do it to get maximum impact, in my personal opinion. And my hope is that this will change, right? Like as we get better at doing async, as the ecosystem improves further, these trade-offs will be cheaper and cheaper to make until at some point, like, Django 5 or 6 or 7, you can download, be like, okay, like these things just happen to be async in the background because it's safe. All the guardrails are there. We can just do it for you. Things are magically faster. We are not there yet, however, but that's the future I hope for and really envision. And the real thing here to think about as you sort of architect your code, Asynchro is only for IO-bound code. As you saw earlier in the presentation, it still runs on a single CPU. It's still time sharing. And so if you've got like a really heavy numerical calculation, it will do nothing for you to share that between stuff. Instead, it's for doing things like database calls, network calls, sometimes file system calls as well. Those generally do benefit if you're on any sort of slow or medium speed disk. Those are the things that you want to really do. Now, of course, as web developers, our lives are mostly about IO code, right? Like we are literally always taking requests and sending responses and doing all that kind of stuff. And so for us in particular, I do think there are 3 key places that really make sense for asynchronous support, both now and also in the next couple of years as it really builds out. The number one thing is parallel queries. And I saw a question about this on the Django forum this week. Someone had come across from Node and gone, well, in Node, I can do ORM query 1, ORM query 2, ORM query 3, and then just parallel them and execute in parallel. How to do that in Django? It's a really sensible question, and unfortunately one we can't quite do yet. But if you've got a view or some piece of code that sits there and does like 10 different unrelated queries and then builds a page out of it, those should absolutely run in parallel. You can probably make your view like 100%, 20% faster, honestly. Well, not 20% faster, but you make it way, way faster just because database calls are often the slowest part of any web application that's any significant size. And again, like if you look at the bottom point on this slide, that's kind of true even if you're a much bigger site that's sort of like, oh, well, we don't have like just database, we have microservices, we have domains, we have like APIs between internal stuff. Like, again, you're just doing network calls. If I come to your front page and it calls 10 different servers to render 10 different portions of the page independently, you should absolutely call those 10 things in parallel and then compose the result when they all come back. You're going to save so much time. It's going to take only as long as the longest response, not just all 10 of them. And that's really the kind of thing I think that's going to give us massive leaps and bounds in web performance over the next 2 or 3 years, is the ability to just mix those things in. Like my vision for Django is like, once you've got the ORM done in async mode, you'd be like, oh, well, this view does call like 5 or 6 different things in parallel. You can pop async on it. You can take your queries and put them in a big parallel call and you're done. Like, and it's that simple and it's safe. That's kind of the vision I think all of these things cover, along with, service stuff. And finally, of course, notifications and events. I discussed this earlier. I think sockets they're not a huge part right now. WebSockets never really took off in the way some people thought they would. I was always like, well, of course, they're a very niche thing, right? They're for like games or chat systems, anything that's real time. So they probably won't ever take off in a huge way, but I think a big portion of the web will always need them there somewhere. And of course, there are third-party services that will do all this for you in notifications and polling. And in some cases, I'd say just use them. They solve a lot of the hard scaling problems for you. Scaling long polling of sockets is totally different from scaling and load balancing normal web requests. However, you will probably all come across this at some point. And I think, long polling at least, or some kind of system like that is going to be a thing that's happened there as well. There's also things like server-side events. There's lots of stuff where the server wants to send that kind of response after the fact. So I guess the question I want to sort of tie into the end of the talk here is, what does this mean for you, right? Like I have spent, if you see, like over a decade immersed in asynchronous stuff. Honestly, at university, I loved all the sort of proof languages about how to do things in parallel and deadlocks. I've always been this kind of person. But I think it's very different for the sort of, your normal web developer who's just doing stuff and building systems, be they big, be they small. And I think what it means for you is, what I ask of you is, I think the time is almost here that like, this has to be a serious consideration in how you build out new things. It's not at the point now where you should go and rebuild everything else, unless you have a really like socket heavy thing. But like we're getting to the point in the next, 6 months to a year where I'll be like, well, you probably should just be thinking about this. We're probably in a place where, hey, you can just mix in things and do them as you want to. Mixed mode stuff is coming. Django has sync and async views, and they do just work for the most part. There's a few edge cases, but they're mostly guardrailed. The Flask issue for adding async support has made some amazing leaps and bounds in recent times. Like I'm sitting there watching the issue being like, oh, this is good, let's go. And like helping out in little pieces where I can. But like, we are getting there. We are getting to the point where like, you can just use this stuff in production in a reasonable way. And there is library support for it. I think at that point, the question really becomes, what are you building and how would it benefit? And again, I don't say always take async code and run it. That's not the conclusion you should draw from this. If anything, it's the opposite. If you have to pick something, if you are unsure, prefer the good old synchronous way. You'll be much happier with all the existing documentation and code examples. But I think we're at the point now where you can look at your architecture and like, even if you're not doing async stuff quite yet, you can start preparing for it. You can start like, arranging the chairs in the right way. Take all your queries and, put them in one block and make sure they don't, make them as non-dependent on each other as possible. You can separate out like heavy calculation logic from IO logic. You can do all these kind of things. So like when the time does come, you can get a really nice profile of where you spend your time on input output versus like CPU thrashing. And B, if you want to convert it, you've got a nicely arranged piece of code now that you can take and just apply async to, and it will hopefully give you a massive performance boost. But of course, number one thing I think is to get a feel for this stuff, experiment. If you are a Django user, please just like make sure in Django 3.1 or even the almost released 3.2, just type async def into review and guess what? It'll just work. It's kind of, I'm still really pleased about that. It kind of just works in a really great way. When other frameworks add it too, like just try it out, like get a feel for it, like understand and like start to take in like, well, this is how I sleep. There's a different sleep command. Here's how I do network requests, and here's how I make sure things are okay. I have a few guides and talks online about how to do that in a particular way and like turn on the debugging flags. But that's the kind of thing I think, like getting familiar with it. So like when the time comes, you know how to apply and what to apply and what its benefit is. That's what I would encourage you to do. And of course, finally, I would be remiss not to mention the fact that like this stuff is all built by people like you and like me. I do build some of this stuff. Open source is a wonderful thing. And in many ways, it depends on all of us contributing back, right? If you have a particular thing you want to see, you may be the best person to work on it. And this is true of Django, this is true of many other open source projects. I can't speak for anybody else, but like every open source maintainer I know who is facing down the barrel of, especially like the smaller libraries who are like, oh God, people want async support, what do we do? That's the kind of thing where like it can help to step in. And also, I will say, especially if you are new or like sort of semi-new to open source, it's the kind of big feature adding code that is much easier to sink your teeth into. Like it's not like, oh, here's a bug from 2004 that no one's ever solved. It's much more like, oh, here's an existing API spec that you need to replicate and make feel good. Like to me as a new open source developer, that was the kind of thing I love. That's what like Django migrations was that thing for me. And so if you want that kind of challenge, I would really encourage you to go and talk to your favorite open source project about it if they are open. Don't push it on them, but many people are looking for help. Open source always needs your help. So with that, I wish you good luck out there in the async world. Thank you very much for having me on, and I will see you all around.